Hello students and welcome to my channel Maths Hub. So in this video, I will be talking about multiple integration and we will focus on change of variables. So in this particular video, I will be talking about how to change Cartesian system to cylindrical coordinates, right? So if you haven't watched my previous video of change of variables from Cartesian to polar, do watch it. So we have discussed all that already this one. So in this particular video, I will be talking about how we change Cartesian coordinates to cylindrical coordinates. And in my next video, I will be talking about converting Cartesian coordinates to spherical polar coordinates. So now let's try to understand what are cylindrical coordinates. Now in a cylindrical coordinates, we have our system in x, y and z. So suppose we have any point P, x, y, z in 3D. If I take its projection on the xy plane, so projection means that if this is a point in the space, you are just putting a torch over it on the xy plane. So we will get a point over here, right? So now from this point, let us join the origin with this point and let the distance be marked as r, right? So this distance is r. And now we will draw perpendiculars on the x-axis and the y-axis. So this distance becomes x and this distance becomes y, right? So according to simple trigonometry, if I take this right angle triangle, I can quickly calculate the values of x as r cos theta and I can calculate y as r sin theta, right? So z will remain same, the height of this, right? So now as I convert Cartesian to cylindrical coordinates, so I can see that here triple integrals will be used. There is a function in x, y and z and the order of integration can be dx, dy or dz. And now when I convert this into cylindrical coordinates, what is the change? We will have the limits accordingly. The function in x, y, z will change to r theta, z will remain same. So you can see that x is r cos theta, y is r sin theta and z is same as z. And now your dx, dy, dz will change to Jacobian. So whatever is the Jacobian, we will have dr, d theta and dz along with it, right? So the first step is to calculate the value of the Jacobian. So what is the Jacobian? Jacobian is basically the change of the new system, that is x, y, z, with respect to the the change in the old system, that is x, y, z, with respect to the new system, that is r theta z. So let us write the determinant. So it is del x by del r, del x by del theta, and then we have del x by del z. Similarly, we have del y by del r, del y by del theta, and we have del y by del z. Likewise, we can convert del z by del r, del z by del theta, and del z by del z. So let us fill up the values of this determinant. And when I fill up the values of these determinant, since x is r cos theta, so del x by del r will be cos theta. Del x by del theta will be minus r sin theta. And del x by del z is equal to 0. Likewise, del y by del r is sin theta. Del y by del theta will be r cos theta. And del y by del z is again 0. Now del z by del r is 0. Del z by del theta is also 0. And del z by del z is equal to 1. So if I expand from the bottom row or maybe by the last column, what do I get? I get r cos square theta plus r sin square theta. So that will turn out to be r. So that means the Jacobian of transformation when we are converting Cartesian to cylindrical coordinates, that is also r. So if you have checked my previous video, you will find that when we were converting Cartesian to polar coordinates also, the Jacobian of transformation was r only, right? And accordingly, whatever the region is given to us, we will be calculating the limits of the integration. right? So we will calculate the limits of integration accordingly. So let us move on to the first question. And before we move on to the questions, one very interesting fact is that when do we do the questions on cylindrical coordinates? Basically, cylindrical coordinates fit good for describing cylinders whose axes run along the z-axis and the planes that either contain z-axis or they lie perpendicular to the z-axis. So here you can see that if there is a circular base in the xy plane and we elongate that base along the z-axis, we will get a cylinder. So it is very beneficial when we do the questions of cylinders with cylindrical coordinates. They become easy to solve, right? So we'll try this exercise now. So by transforming into cylindrical coordinates, you need to evaluate the integral triple integral x square plus y square plus z square dx dy dz taken over the region 0 less than equal to z is less than equal to x square plus y square less than equal to 1. So let us try to convert the integral first. The integrand is x square plus y square plus z square. So we know that whenever we are converting Cartesian to cylindrical coordinates, your x is r cos theta and y is equal to r sin theta. So when you square and add them, you will get x square plus y square is equal to r square. So it is r square plus z square. Now the Jacobian of transformation is r and we convert dx dy dz as dr d theta and dz. Now what are the limits of r theta and z? So if you check the limits, it is given 0 is less than equal to z is less than equal to x square plus y square is less than equal to 1. So what will this imply? It will imply 0 is less than equal to z is less than equal to r square is less than equal to 1. So you can see that the limits, lower limit of r is 0 and the upper limit of r is 1. So r lies from 0 and 1. Now since r is equal to 1, that means it is a circle whose center is at the origin and radius is equal to 1. So if you check the coordinates of theta, since it's a complete circle, so theta will lie from 0 to 2 pi. And where will z lie? Z will lie from, you can see that z is bounded between 0 and 1. So z will also lie between 0 and 1. Right? So now let us try to perform this integral. The innermost integral is with respect to r. So we have 0 to 1, 0 to 2 pi integral. R square into r is r cube. So it is r4 by 4. And the second term is z square is constant. We have r. So r will become r square by 2. Limits from 0 to 1. And we have d theta and dz. So that will turn out to be 0 to 1, 0 to 2 pi, and we have 1 by 4 plus z square by 2, and we integrate it with respect to d theta and then we will integrate it with respect to dz. So now for the next integral, we have to integrate with respect to theta. So this term will be constant. So we will have 1 by 4 plus z square by 2 integrate with respect to theta, put the limits from 0 to 2 pi, and the final integration is with respect to z. So that will become 0 to 1. You will simply have 2 pi. So 2 pi is constant. I can take it out. And then I am left with 1 by 4 plus z square by 2 integration with respect to dz. So that is finally 2 pi. And then we have integration of 1 by 4 is 1 by 4z. And integration of z square by 2 will become z cube by 6. And we will place the limits from 0 to 1. So that is 2 pi. And then we have 1 by 4 plus 1 by 6. So how much is this? 2 pi and then 12 is the LCM. So I will get 3 plus 2. So that is 5 into 2 pi by 12. So that cancels and we get our answer as 5 pi by 6. Right? So I hope this question is clear. So now we move on to the next question, which is also a conversion from Cartesian to cylindrical coordinates. So using the cylindrical coordinates, we need to evaluate triple integral over the volume V, x square plus y square dx dy dz, taken over the region V bounded by the paraboloid, that is z is equal to 9 minus x square minus y square, and the plane z is equal to 0. So let us try to calculate the integrand first. So x square plus y square will become r square. The Jacobian is r, and then we have, you can place any order, dz, dr and dθ. Now from the given limits, I can see that the lower limit of z is 0. And when I put the values here, I will get z is equal to 9 minus x square plus y square, which is equal to 9 minus r square. So the limits of z will become 0 to 9 minus r square, right? Now once we solve the innermost integral, z will go. So I can put z equal to 0 and I will get r square is equal to 9. So if r square is equal to 9, then r will be 3. And since it is bounded by z equal to 0, so the lower limit of r will be 0 to 3, right? And since when I take its projection, it will again be a circle in the xy plane. So theta will always move from 0 to 2. So now let us try to solve this integral. So the innermost integral is with respect to z. So rest all the variables are kept constant. So we have 0 to 3. R cube is constant and we have z. Let's put the limits from 0 to 9 minus r square and we get dr d theta. So that finally becomes 0 to 2 pi integration 0 to 3. R cube is constant. So we have r cube into 9 minus r square dr d theta. So now this becomes 0 to 2 pi. Now when I open up the brackets, I get 9r cube. So integration of 9r cube is 9r4 by 4 minus r cube into r square is r5. So it is r6 by 6. Limits are from 0 to 3 and then we have d theta. So that becomes 0 to 2 pi. When I put in the limits, 3 into 3 into 3 into 3. So that becomes 9 by 4 into 3, it's 81. So it will become 729 by 4 minus, let's put in here. So 3 into 3 into 3 6 times and it is divided by 6. So 1 will get cancelled. So 3 3s are 9. 3 3s are 9. 81 into 3 is 243 divided by 2, right? Multiplied by d theta. I'll get this term. And when I simplify it, what do I get? 729 minus double of 243, that is 486. So we will get 243. So 243 by 4. And when I integrate it, I'll get 0 to 2 pi d theta. So that is simply 243 by 4 multiplied by theta. And when you put in the limits, you will get 2 pi. So 2 cancels and we get the answer as 243 pi by 2. So this is your answer, right? So I hope this question is clear to all, right? So if you still have any doubts when you are converting Cartesian to cylindrical coordinates, do put it in the comment section and I will reply it back. And if you like the video, do hit the like button. And if you haven't subscribed my channel, do subscribe my channel to get the latest updated video. So thank you for watching. Have a nice day and believe in yourself. You can definitely achieve it.